Hello guys, today I am going to show you how to do some energy calculation by using PSPICE. Most of the YouTube videos I have seen, they are doing power calculations using the power probe. It's obvious that we can use voltage probe, current probe and the power probe in the PSPICE. Very easily we can measure the voltage or current or the voltage amount of power using by some equipment, some element, by just using that probe in the PSPICE. Here you can see VIW, but how to do some energy calculations, that means W times time, integration of the power with respect to the time, how to do that, right? For that, let's consider a very simple circuit. Here I'm using an inductor, resistor and a capacitor. The basic circuit, our RLC circuit, right? And then I'm going to use a battery. DC source, this is not much familiar to me. Place sources, voltage source DC, right? Here it is better to do some transient analysis. Switch, I will choose the basic switch here. On switch, as I remember it is T on something, T on switch. Switch, there are plenty of switches in PSPICE. I want the basic switch to simulate the transient analysis of this circuit and calculate the energy absorbed by these elements and dissipated by the elements like resistor. So here, switches open at T, right. This is my switch. It's sorry for the alignments. Alignments are not well marked. Here is the ground. We should use the ground with this 0 mark, right? Let's consider the default values. Here I put 12 volts. And on time I will choose 300 milliseconds and new simulation profile. I set it the simulation time to 1 second, right, and simulate this. Now I want how much energy dissipated across this resistor and how much energy absorbed by this inductor and capacitor, and how much energy gave to the circuit by this voltage source. So how to calculate the energy? So this is the empty trace. So let's trace. Here I will choose the power. I put tick to this power position. Here I have R1. So if I plot this WR1 with respect to time, what I have, what is this? Just 0. Why is it 0? Let's reduce the resistance 1 ohm. Then simulate. Right, trace at trace. What? Here, this is the power. It's a very small power. Let's put this to 230 volts DC. It's fine. I need some considerable amount of power dissipation value. Put these to 100 microfarad. Now let's check. Sorry, that is not Henry. No? 100 microfarads power of this resistor. Now when I simulate this, why the power is too small? Right, because of this capacitor, it blocks the power. Right. Check. Right. Now this is the power dissipated across the resistor. Right. At 0.3 seconds, it will cut off. So now how to calculate the energy? Energy means we have to integrate this power with respect to time. Trace, add trace, integrate here. This S is for the integration. SWR1 here. This is the cumulative energy. At 0.1, energy dissipation across the resistor is 0. At 0.3, energy dissipation across the resistor is approximately 15 kilowatts. These are ideal values. Normally a resistor cannot handle this much of energy, right? But for the sake of easiness, I use the power dissipation of the resistor. So this is how we can do the energy calculations across any device. So let's see what is the energy absorbed by the inductor. SWL1. So this is the energy absorbed by the inductor. What is this? Here I have to set the initial current of this inductor as 0. Now let's try. Right. So when the switch is on, right, this is the power. So let's trace the integration of power across L1. There is 0. There is not 0 with respect to the power, it is negligible. Right. So this is the energy calculation across the inductor. At t is equal to 0, the switch closes. There is energy spike across the inductor. Then when the switch turns off, what will happen? Energy reduces. Why? Right now we will get the simple idea of how to do energy calculations by using PSPICE. Let's remove this. Now put this into 700 milliseconds and measure power across this resistor and inductor. And these are the power values. Energy. Assume we are interested to consider the absolute values of power. So I would like to integrate the absolute value of ABS or WR1. Let's delete these two. And I would like to trace integration of the absolute value of WL1. WL1 is negligible compared to WR1. Let's delete this. So this is the energy calculation. Right. Just integrate the function, integrate this S. Integration means this S. Here we have lots of notations, lot of operations, absolute value, average, cosine, exponential, integration, differentiation also include here. I don't remember it here, D, not sure, right? So that is how we can do energy calculation by using PSPICE. So thank you for watching. Have a nice day.